folks. Thanks for coming. Welcome. I am Vanessa Gennarelli, and I am the General Manager for GitHub Education. And I'm very honored to be the one to introduce Dr. David Malan and the CS50 team. Because many computer science professors are heroes, but few are household names. David is the mastermind behind CS50, which is Harvard University's largest MOOC and largest course and edX's largest MOOC. Behind CS50, the CS50 banner, is a well-oiled machine. David has 102 TFs, about that. And he throws a year-end, a semester-end event, the CS50 Fair, which actually you'll notice that there are little rubber duckies outside. It actually is a 10-foot tall rubber ducky. And he even has his own TV show where he connects computer science concepts to current events. Today, he and his team will be talking about the tools that he has developed for teaching and learning with GitHub. Lots of teachers use GitHub as a tool. David is unique in that he uses GitHub as a platform, building with our API and stress testing all of our endpoints. Now he has open sourced these tools, and he and his team will walk through their development and their pedagogy behind it and how you can implement them in your courses. Please welcome David Malan and team.
Well, thank you so much to Vanessa and to GitHub's whole team for having us. Frankly, that feels like a lot of pressure now. So the goal at hand is really to give you a sense via a fire hose of sorts of a number of CS50's tools, all of which are freely available, most of which are available as open source too, so that you can modify them and contribute back to them if you would like. And then just a bit of background. The team that you're about to meet includes Chad and Jelle and Erin and Kareem, and they too will demo some of the problems to be solved and some of the solutions there too in the coming minutes. First of all, foremost though, thank you especially to our friends at GitHub who not only have offered us the stage today, but also tomorrow. If you're at all interested in learning more hands-on about every one of these tools and actually playing with your own laptop, feel free to join us. If you register in the usual way, they'll kindly reimburse you for the registration fee, so it's effectively free. If you'd like to join us tomorrow at 3 p.m., you can just search the online schedule for CS50. And then a number of the tools you're about to see are also built atop other platforms, namely Amazon's cloud service and Google's, as well as Next Tech as well. So we're in good company and on the shoulders of some amazing friends. And here is Workshop 408, to which I alluded just a moment ago. So that's how you can get more information. What's the information you're going to get now? So the whirlwind tour ahead is to introduce how we in CS50 go about building scaffolded lessons with CS50 Lab, which is itself built on top of another tool of ours called CS50 Sandbox, which is a free programming environment for students and teachers. How we go about having students and anyone out there submit code via a tool we call Submit50. How we go about testing students' code via a tool called Check50, how we go about checking the style of students' code via a tool called Style50. There's perhaps a pattern emerging now by now. And how students and TFs alike go about understanding error messages with a command line tool called Help50. And comparing submissions via a new tool called Compare50 for reasons of academic honesty and the like. You're certainly welcome to photograph the screen and such, but if you also go to cs50.ly/talk, the same slides are there in real time as well. So without further ado, CS50 Sandbox is one of the tools, as Vanessa notes, that's built on top of GitHub, particularly for authentication. Indeed, beyond GitHub offering students repositories and Git functionality, there's also the ability to have authorization and access controls and a storage backend effectively. And across all of the tools to which I already alluded, there's these sort of common needs and plumbing, if you will. And so we've indeed made a very conscious choice in recent years to build a number of these tools on top of GitHub, really using it as a backend infrastructure. So frankly, we as teachers can focus really on the pedagogical aspects of these tools and much less on the underlying cloud and technological backends. So CS50 Sandbox aspires to enable students and teachers alike to create temporary programming environments, otherwise known as sandboxes, that they can then use very quickly, similar in spirit to REPL.it, if you're familiar with that particular website. And then also enable students and teachers to share the copies of those sandboxes with each other, so that they can actually continue working or filling in blanks or seeing sample solutions. So the use cases, for instance, for us, for this particular tool that you're about to see, are scenarios like this. A teacher stands in the front of the room and just wants to do a quick programming demo. They don't want to necessarily have to log into a big system or configure a new project or futz with menus. They just want to focus on code or some problem. That's one of the goals we've aspired to solve. Sharing starter code with students. Hey, class, everyone, go ahead to go to this bit.ly URL /1234, and now you'll have a copy of whatever my code is as the teacher, because I'd like you now to fill in some blanks, would be a second use case for this tool. And then lastly, distributing sample solutions where you have some uncompiled code or even compiled binaries that you want to make available to students, but you don't want them to have to figure out how to download it or re-upload it or put it in the right place. You just want them to be able to run a command. That's a primary use case for this as well. So if you go now, even today, to sandbox.cs50.io, you'll see an interface like this, and you'll be asked what user interface mechanisms you would like. It's required that you have a terminal window, because indeed what we focus with students on is not toy environments or simplified environments such that we're hiding some of the underlying implementation details, but the terminal window is the mechanism via which in many of our classes do we have students actually interacting with the system. Here, pre-checked as well as a text editor via which you as the student or teacher can, of course, then edit any of the files you're about to see. There's other features as well that you'll see a glimpse of in a little bit. You can have an embedded browser window to keep the student in situ so that if you're doing experimentation with HTML and CSS, everything's all within this same window and environment. And even support for X windows, whereby you can have graphical apps in Java, Python, maybe some other languages. Not great for animations or interactivity just because of the latency with any cloud, but certainly for more interactive programs that aren't highly moving, visually does this work quite well. And so this is what it looks like. And you'll see that we have very carefully screenshotted everything today, lest the hotel's Wi-Fi not cooperate. But all of this is live right now, and you can play with it in real time now or tonight. This is what a student would see after clicking Create to create his or her own sandbox. At the top of the screen is their text editor. The bottom of the screen is their terminal window. And in this case, we have an arbitrary program written in C via which a student could now run make hello or some similar command to actually compile it. If, though, they click on that box at the top right that says share via this automatically generated bit.ly URL, can they then share this with their class? The idea being if a teacher's been doing some work in real time and he or she wants to say, all right, class, go to this URL so you can pick up where I've left off, go to that URL. The student will be automatically whisked away to a copy of whatever is pictured in the screen right here and not have to do any commands. They'll just be redirected to their own unique URL identifying it. But there's some more sophisticated features, too. A few things that we realized, oh, wouldn't this be nice too if we really wanted? So if you actually click on Customize on that main landing page, can you actually run a sequence of commands a la a bash script if you want to configure the environment with apt-get or pip install or any number of other commands because we don't ship what you want to use in your class? Can you run those commands by default? And if you also want to confine the terminal window to a Python interpreter or R or something like that, can you actually confine it to that instead of running a typical shell like bash? In terms of the environment supported, Python, C, C++, Java, JavaScript, HTML, CSS, R, SQLite, and a bunch of others. And frankly, after this, if you find something not on the bulleted list, if you click on environments, just email us. And so long as it can be installed in Ubuntu 18.04, we can oblige for you. And underneath the hood, what students have, thanks to our friends at Next Tech, is just their own container virtualization technology via which they have full-fledged control for however minutes or hours or days they're using that sandbox in which they can install anything they'd like. And there's an API built into this as well, so that if you want to paste links into an assignment and to create a sandbox on demand, which we ourselves use for homeworks, you can parameterize URLs like this, sandbox.cs50.io /? File equals hello.c, window equals editor, window equals terminal. And that, as those terms imply, will create exactly an environment with that file and with those GUI windows as well. And so we commonly paste these into our problem sets or homework assignments just so that students can click one thing and immediately get an environment that's exactly as we intend. And you can get even more fancy here with additional files, a browser window, and so forth. They're just simple HTTP-based URLs. So what are the underlying implementation details? As much as we can, we try to stand on the shoulders of others, certainly our friends at GitHub. In this case, we're using Bitly's API. They're the URL shortener service, as well as Next Tech, who helps out with the underlying containerization where students can actually write their code. So that's more utilitarian. That solves a number of use cases in the classroom. But it would be nice, we realized quite quickly, if we could use this for our homework assignments themselves and really start scaffolding students' learning and their completion of problem sets. In fact, it was only just about a year ago at SIGCSE that in chatting with folks, I realized, frankly, that I don't think we or I have been doing a very good job in CS50, our intro course's first weeks, of really teaching students how to program for the first time. We have very detailed specifications or documents. We have lots of samples, and we give them sample output and input and so forth. But very quickly did I realize in conversing all the more with others that wouldn't it be nice to help students just take individual steps and help them decompose problems that for all of us would be pretty accessible, but really help walk them through it in the spirit of Codecademy and CodeHS and a lot of these web-based platforms these days that do a really good job at exactly that. But we at least have been averse generally to sort of buying all into some platform and effectively teaching our course and our pedagogy and conforming to some other platform. We'd much rather use free and open source software as much as we can, use version control, not have to use someone else's GUI that invariably isn't going to do quite what we want. And so we want to use a lot of the lower level implementation details, but build on top of them things that support the classroom as opposed to vice versa. And so thus was born CS50 Lab, which essentially uses CS50 Sandbox as a building block, adds in GitHub as an additional layer, and adds in a Codecademy style interface via which teachers can write their very own lessons. The use cases here being to enable teachers to create step-by-step programming lessons, or we call them labs, providing incremental feedback with each step, and then enabling students ultimately to progress, for instance, from an empty file or maybe some starter code to a full-fledged working program with hints and feedback from us, the teachers, along the way. So here's a glimpse of this user interface. It's really the same thing, but we've added to the left-hand panel what looks like HTML-based instructions. And it can be paginated, as this next button implies, such that here is Zamila, one of our longtime teaching fellows, who's there to give a verbal and a visual walkthrough or overview of the problem. When the student clicks the next button, do they then see the next step? And so in this case, this is one of our more canonical problems. We have students implement Mario, or sort of an ASCII-based version of this pyramid here. And this is a perfect example of what I mean by scaffolding. This has for years been one of our first homework assignments, whereby we ask students in C, after a week or two of exposure, to write a program that just prints out a pyramid like this. You know, it's not terribly hard, but if you really start to break it down in your mind, you know, I have a variable number of spaces followed by an opposite variable number of hashes, and there's some non-trivial implementation details there. And we found ourselves with each passing year explaining to students in office hours or classroom environments like how to build up from nothing to something. And yet our homework assignments, the specifications, really didn't do them that same service. We relied on humans to explain, and this was just bad pedagogy. And so via this tool do we hope to just support what we do in person anyway, but just keep the technology out of the way and enable students to focus really on step by step. So for instance, in this case, we realized that we generally, in office hours, encourage students to start with pseudocode. So step 3 here is here's the pseudocode. You'll notice in the sandbox, there's an empty tab here, which they could click and actually type in their code for us. And then on the left-hand side here, we can even have spoilers, or which in this case we do, just in case a student has no idea what we even mean by pseudocode. Well, that's fine. It's completely up to them to opt in and say, show me more. We'll give you the answer. But again, sort of approximating what you might do in person more naturally, but only revealing as a student wants. Here, for instance, is how we, in this very specific case in this course, scaffold students toward that pyramid that's technically right-aligned. We say, don't do that. Do this left-aligned pyramid first, which is actually easier because this is like a for loop with I is 1, 2, 3, 4, and that's a lot easier than doing the invisible spaces and then right-aligning it. So we do that as the next step. Via a button, can we get some additional hints for the students? Here we might then say, we first say, you know what, go ahead and put dots there. The simplest of ideas, but just put dots there so that you actually see it. Because most students don't actually realize that by right aligning it, we just mean hit the space bar that many times. And we take these kinds of things for granted. We can easily explain in person. But again, via a step-by-step approach, do we want to encourage them to do that? Then the next step is remove those dots, which is pretty trivial. You replace the period with the space character. Here we spoil it with this particular hint. And then ultimately is the last step, submitting the actual work. And so for this, we have a tool called Submit50, which we'll expose in just a little bit. So long story short, this is partly just about our own particular pedagogy for this particular problem. But we just wanted a tool to make that thought process and methodology easy without buying all into someone else's system, learning someone else's GUI, risking that 2 years from now that tool might not be around and we therefore now have to recreate everything. We just wanted to keep everything in publicly accessible Git repos or GitHub repos in this particular case. So how did we build this tool? CS50 Sandbox, that first tool, composes half of the user interface. We added onto it GitHub, whereby the lesson on the left-hand side you just saw is just a markdown file, if familiar, a text-based format that very easily gets converted to HTML with some custom plugins lessons we wrote to give you those green buttons and the hint feature and the like happens to be using Jekyll, which is the same tool used by GitHub Pages, if you're familiar with that free hosting service. Markdown is the language, and then YAML underneath the hood is a configuration file format, essentially, via which students, or teachers rather, can create that lab. So before I turn things over to Kareem to give an actual demo of creating one of these lessons that you yourself can do, notice here too, we just wanted this to be completely self-service, not for just us in Cambridge, but really any teacher on the internet, high school or university. And so if you simply go to a URL like this, lab.cs50.io something, that something is completely self-service. This happens to be in our CS50 account on github.com, in a repository called labs, in a branch called SIGCSE, in a folder called Mario. The idea being you don't have to have a CS50 account. You don't need to talk to us at all to request access. You just create a GitHub repo and then append those strings from github.com to lab.cs50.io, and it automatically just works. So the general URL format here is :user, :repo, :branch, :path, which means, again, all you need is a free GitHub account, put the files there, and we, upon seeing a student visit a URL of this format, will clone your repo, specifically this repo. We'll check out this branch. We will then run Jekyll, that command I alluded to earlier, to convert your markdown into HTML, and voila, everything just works. And so here we have a highlighting version of that same idea that maps ultimately to this example that I just posited there. Specifically on GitHub, could you access the source code for that same lab here? The only anomalous is this, which is a github.com specific thing, but everything else maps perfectly cleanly. So how do you go about creating a lab? You simply create two files. And I think for this step, allow me to turn things over to my colleague Kareem, who's been instrumental in this and many of our other tools.
Thank you so much. So I'm going to walk us through creating a CS50 lab, or a lab in general, and that's not what I want. Can we cover? Oh, sorry. OK, there we go. OK, so for this, I'm actually going to use like GitHub's own user interface. But if you're familiar with Git, if you prefer using your own like local system, you're welcome to do that as well. And so to get started with this, the simplest thing that we need to do is just create a repository on GitHub. And we can do this by visiting github.com/new, assuming you're logged in already. Yeah.
Can't hear you well. Can you get the microphone closer?
Oh. Sure. OK. Thank you. All right. OK. So the first thing that we need to do here is basically create a GitHub repository. And you can do this by going to github.com/new and then filling in the form there. And then I created one already. I created a folder within this repository. I'm going to start with lab 0 here. And this folder needs to have minimally one file. This file is called cs50.cs50.yaml. Let me zoom in here so that you can see. And minimally, to get started with a lab, all we need to do is actually just do add this key, lab50, :true. And then let's commit our changes. And then once we've done that, we can just follow what David just demonstrated by copying this link here. So this lab is going to be under lab.cs50.io/my username / the repository name, and then the branch name, and then the path within this repository in which I created this lab, which is lab 0 in this case. So if I hit enter here, hopefully, OK. So what we get ultimately is this. And this is based on the same sandbox environment that David briefly demonstrated here. And as you can see, in the top half of this screen, there's a place for a text editor where students can create new files. There's a file browser here on the left that's hidden by default. But this is where students would navigate their files if they have any. And there's a terminal tab here at the bottom. And this is also a terminal for Ubuntu 18.04 as well to interact with their environment. OK, so pretty simple so far. Let's go ahead and add more stuff. So how can we add these instructions to one of these labs? So again, I have my cs50.yaml file here. I need minimally to have my key value pair, lab50, and then :true, and then commit my changes to save this file. And then all I need to do to add instructions is actually create a readme.md file, as you can see here. And this readme you typically find in other GitHub repositories as well. It just uses GitHub flavored Markdown, and then we can add our instructions pretty easily, like in the same way. So I'm just going to call this my lab, and I'm going to say these are my instructions. OK, so I'm going to save this, and I'm going to commit it to my repository. And then I'm going to do the same thing. Visit lab.cs50.io, CS50 student 2, repository name, branch name, and then path, which is lab 1 in this case. So once I do this, assuming nothing went wrong, I should see on the left, as you can see, my README rendered as I would expect it to be. All right, so also on the right here, I find my README also open in the student's sort of this sandbox environment, which is not really what I need in this case. So how can I get rid of this? And the answer is very simple, actually. So if you go to lab 2, I realized I should have done these steps before, actually, to just avoid duplicating things. But again, we're actually going to add more stuff here. So in this case, by default, everything, all the files, except, of course, .cs50.yaml in my lab are included and also opened in the text editor, as we see here. So to override this behavior, I need to have another key called files. And this key is going to be a YAML list. So this file, in this case, I need to exclude everything by default instead. So I'm going to do bang exclude, and then star. So that means exclude everything. And then I need to just include the file that I care about. So this file, if it exists in the same folder as .cs50.yaml, it's going to be opened by default in the lab environment. Otherwise, it's going to be created for you and opened also by default, but it's going to be empty. So you can imagine having some distribution code if you want to have that. So that would exist by default. Otherwise, it will just be created for students. So I'm just going to call my file foo.c, and then, sorry? Get rid of what? Sorry. All right.
Don't mind me.
OK. OK, so this is how we do this. Sorry about that. All right. So let's commit our changes. And again, whoops, sorry. Go to lab 2 instead in this case. Let's see what happens there. All right, so there's my lab. I missed my instructions because I don't have my README file, but I can create this pretty easily again through GitHub's user interface using this. And then I'm going to call this my lab again. And then commit this file. So here's actually something. So I changed something in this lab. To get these changes to reflect, what I can do is click this pretty small reset button on the top right corner to reset my lab to the latest state. And this also helps in case you need to make updates after releasing one of the labs. You can just ask your students to sort of reset this lab. With one thing, like one catch though, is that when you reset a lab, if you have any data in the lab, unfortunately that's going to be lost. So if you end up doing something like this, it would be advised to ask students to download their files first and then reset the lab. Maybe we can work on something to fix this in the future, but for now, that's just the way it is. All right, so let me move over to adding a few more content here. So these instructions, as we can see, we can add steps. So let me add, instructions for step 1 here, instructions for step 1. And then to add that next button, as David demonstrated, we can just do this. So brace, %, next, and then %, brace. All right, so we can commit these changes. And actually, so by default, this is still going to be one step, right? We need to add another step. So sorry about that. So we're going to do that again. So step 2 here. More instructions if you want. All right, so let's commit these changes. And let's reset our lab here. And here's what we see. So this is the first step of my instructions. This is my next button that I just added. And if I click next, step 1 gets hidden by default, and then step 2 shows up with the instructions for this specific step. So what else can we do? We can also add all sorts of things like videos and such. So the way to add a video, and I'm just going to add a different step here. So let's go to step 3. And then the way to add a video is the same, pretty much the same way. So I'm going to mention video, and then I'm going to just type a YouTube URL. So youtube.com/watch_v equals, oops, I actually forgot to have this. So let me rg 8b1wh All right, so here's my video. And if I commit this file and save, and again, reset my lab, here, I'm going to have, I should have my, oops, did I miss something here?
I'm not seeing it.
OK. All right. OK, so let's, OK, so I'm not really sure what's broken here. So let's actually go ahead and move to the different step. So OK, just to mention it, to create a spoiler as well, it would be pretty much the same way. So it would be the same way you'd have a video or a next tag in Jekyll, so spoiler. And then you can rename the caption on the button that this spoiler shows if you want. So you would mention some new caption here, and then at the end here you would say end spoiler. And right here in the middle, there will be the contents of the spoiler, and these can be normal markdown like you have in these instructions in the README. All right, so I can add, inline code or code blocks in this case. So this would be a code block. If I need to add inline code, so regular markdown formatting of GitHub as well. OK, so all right, so there's a couple more features that also exist in Lab. One of them is the browser window that David showed, and these would be also in the CS50 YAML file. They would be added. The X window as well. Just we're short on time here, so I'm going to give things back to David to talk more about that.
Cool. Thank you so much. Yeah, as Kareem noted, via the CS50.yaml file, can you parameterize even what types of windows actually appear to the students? And so here, when Kareem was each time doing lab 50 true, this essentially just means enable default values. And among those default values is give me a terminal window, give me a text editor, and give me that README on the left-hand side. But we can even override that. And so for instance, as Kareem notes, if we wanted to add not just a terminal window, aka terminal, and an editor, aka editor, you can also embed an X window on the right-hand side to enable graphical programs in Java and Python and other languages, or an embedded browser if you're doing HTML and CSS and JavaScript style lessons. It will simply give you a third slice of the screen dedicated to that particular type of window. And if you'd like to play with any of those features, perhaps the best way is via sandbox.cs50.io. For instance, if I want an embedded X window, I can go ahead and click Create here. And what you'll see here in the sandbox environment is that, voila, now you have an X11 window on the right-hand side that the student can then use too. And of course, the sandbox, as Kareem notes, can be embedded by way of that YAML file in your actual lab environment. So any questions before we forge ahead with some of those additional features? No? All right. So it turns out, too, that among the features that the lab environment provides is also the ability, ultimately, to check the correctness of students' code. This is a piece that right now is available via the command line, via tool check50, that Chad will soon be introducing us to. But there's also the spoiler tag, the next tag, and the video tag, to which Kareem alluded. And I'll take the blame for the YouTube video not working. It's probably an unescaped string somewhere. But a check tag soon will be listed as available so that the student can click a button and actually get some instant feedback based on some Python checks that you yourself might have written. And the syntax is straightforward as these, whereby you can embed videos, spoilers here, which is interpreted, therefore, as HTML as well. If you want to create a spoiler, aka hints, you'll get a UI like this. And ultimately, the syntax that we're envisioning for the GUI-based correctness testing of students' code is something like this. This, to borrow syntax from Jekyll, this free open source platform for generating static sites a la GitHub Pages. Check would say, hey, lab, go ahead and put a button here that the student can click to check the correctness of their code. And then using these Jekyll-like conditional expressions, will you, as a teacher, be able to ask questions? Did the student's code compile? If so, just tell him or her yes. Else, go ahead and output, for instance, the standard error that was outputted by that particular correctness test. So more on that down the road. So let's transition. These were our just in case things break screenshots. Let's transition to solving one other problem. So of course, once students have code in this lab environment or any environment, even on their own Macs or PCs, what we're about to do is not tied fundamentally to lab or sandbox. All of these tools are decouplable, is the need to submit code. And some schools, of course, use LMSs, be it Canvas or Blackboard or something else. We have tended to prefer to keep students in a command line environment. But frankly, in our intro classes, we didn't want them to wrestle with git add, git commit, git push, and God forbid, git merge. And so in those first few weeks of the class, let alone first couple of courses, we wanted to use that same infrastructure. Like version control is a very good thing, and free public and private repos are very good things, but we wanted to abstract that away. And so thus was born Submit50, a tool that allows students to submit their work, allows TAs to access students' work, and also enables TAs rather to review students' work thanks to the GitHub.com-based user interface. After all, if you're familiar, you can review code on that platform. You can share repositories on that platform. You can store code on that platform. I mean, these are three big problems that we did not want to have to solve ourselves. We wanted to focus on the course's pedagogy. And so what we decided are these implementation details. Every student gets one GitHub repository. And within that repository, we use one branch per homework assignment. So when a student submits foo or bar or baz as three separate problems or homeworks, those end up as three separate branches on that particular repo. The student has write privileges. Their TA has read privileges, and an instructor or head TA would have administrative privileges. And then we also use some Git tricks using orphan branches so that we can actually have nice clean diffs of their file that show every line as commentable. And so you'll see in just a moment the ability to comment on students' code as well, all via this web UI that we ourselves did not have to implement. All we had to do after creating a repo for a student, either manually or programmatically, is simply say that J. Harvard, the student, gets write access, and their teaching fellow or teaching assistant, TF, gets read access. So how do we do this? Let me turn this over to my colleague at University of Amsterdam, Jelle, for a closer look. All right.
Hi, everyone. Let me introduce you to our first command line tool, Submit50. So what you see here is the entire command that a student needs to run to submit one specific problem, in this case from the organization called CS50 that has a repository somewhere called SIGCSE, a branch called 2019, and a problem called hello. So it's in spirit very similar to how a lab is structured. The same idea, a user, repository, a branch, and then a path to a very specific problem. And we use this same thing to then submit one problem. So it's a command line tool. So in the terminal, a student would run exactly this. And this might seem like somewhat of a long string, CS50, SIGCSE, 2019, hello, but it's typically one of those things we submit with a problem. So a student would just copy and paste this over, and then it's pretty much good to go. Once you run Submit50, you'll see something like this. Quickly jumping over the fact you have to have a GitHub account to use this, because ultimately what Submit50 is going to do for you is push all of that code that you want to submit, or that the course instructor wants you to submit, to GitHub. So you'll be asked to log in with your GitHub account, and obviously you have to fill in your password. Once you do that, Submit50 is going to tell you exactly what's going to be submitted. So you as an instructor have the opportunity, when setting up a problem, to select exactly those kind of things you want to have submitted. And in this case, we're submitting a problem called hello. It's hello world. So the only thing that we submitted here is a file called hello.py. Beyond that point, you'll be asked one extra step to sort of throw up to sort of have the students commit that what they're submitting is actually what they want to submit. And once you do that, the file will be pushed to GitHub. So for the students then, under the Submit50 organization, there'll be a repository per student. And in there will be a branch. And within that branch is that file that was just submitted, in this case, hello.py. For every problem that this student has submitted, and in this case it's CS50 student 2, which we internally also use as a test account, you'll see a branch per problem. And this is kind of nice, because the GitHub UI lets you switch very easily between these branches, and you sort of see exactly what's submitted for the specific problem. And because it's a versioning control system, you can also jump back and sort of see the progress the students have made, or maybe changes that were made between several commits. Then the next step is we get to leverage GitHub for not only storing submitted problems, but also to comment on student code. So as a instructor or for your TAs, they get this view, and they can comment on code per line. And that looks something like this. So you simply click on a line, you get this box, you can type whatever you want, hit enter, and the student will immediately see it specifically on that line. The student then, and this is a work in progress, we're in the process of setting this up, on a website called submit.cs50.io, a student will see for a specific course all the problems that's been submitted, and it will basically be a list like you see here. So in this case, David Malan submitted hello 50 minutes ago. But if there's more submissions for a specific course, you'll see a list of all those submissions. And Submit50 works with several other tools that you're also going to see here today, one of which is Check50, but also Style50. And you'll see the results of those tools for that one specific submission. So how to enable this? It works in sort of the same way as a lab and later also Check50. What you simply have to do is create a file called CS50.yaml and put that in a repository somewhere. And that's everything you need to do. You don't need to tell us that you're creating a problem for students to submit. All you do is you create a repository somewhere that's publicly available and you put this file there. Minimally, it needs to consist of this one line. Just submit50 true. With that, you now have one problem, one slug that will work. That's your username, your repository, your branch, and then a path to where this file lives. And the student can then use that to submit. And by default, everything that is in the current directory that the student is in will just be submitted to a repository for that student. Most of the times you don't want that, though. So we give you the option to specify very specifically which files should be included for a problem. And this is very similar in spirit to a git ignore. And in the past, we've used git ignore to do exactly this thing. But a git ignore has a few very peculiar sort of side effects that don't really resonate with the idea of submitting a problem. So we made it a little simpler, and we just introduced 3 things you can do. You can exclude something, you can include something, and most importantly, you can require something. So for our hello world, I'm just noticing that one says C and the other says Python. But for our hello world example, everything is excluded at first. Then all C files here, but that should probably be Python files, are then included. And very specifically, hello.py needs to be there.
This is just in case they solve the problem in the wrong language. We want to see that.
Yeah, and we could also test that. But this ensures that whenever anything is submitted under this specific slug, a file called hello.py exists. And if it doesn't exist, the student will get a warning. It's like, hey, we expected something like hello.py to be there. Please make sure that that's actually in the directory you're working in right now. So that's Submit50. Let me just...
So now we have students' code in our environment in GitHub repos that the TAs and the instructors can clone. And so step 2, presumably, is to provide them with some form of feedback. They can, of course, provide qualitative feedback now via Git's web-based UI. But if we want to provide automated feedback of correctness testing or linting or style checking of their code, that's where these 2 other tools, Check50 and Style50, come in. So at SIGCSE especially, there's an increasing number of tools and products out there by which you can do automated testing of students' code. There's long been CI/CD services like Travis and Jenkins and so forth. We, for instance, though, for many years had just a whole bunch of spaghetti code that we wrote in a number of languages. And so even we wanted to start to clean up the process via which we write scripts to test the correctness of students' code. And frankly, we also didn't want to be tied to one particular platform. We wanted to use our own tools, or really any tool, but still have access to our own types of scripts. So Check50, you'll see, is a command line tool that allows you, the instructor, to do just that using just publicly available GitHub repos in your own code. And Style50 allows you to check the style a linter of any number of languages, thanks to Chad and our team here.
All right, can we hear me all right? No? How about now? No? How about now? I can talk, I can just speak very loudly is one option. OK, So Check50 is the tool that we use to automatically assess the correctness of student code. So there's two groups for which that's very useful. Teachers, obviously. Teachers and TFs, it allows us to standardize the way that we grade student submissions so that every student gets the same grade regardless of who their teaching fellow is. And it also provides students with a way to, at any point when they're working on the project, figure out how far they've progressed. They can get feedback on what they're doing correctly, what they're not doing correctly at any point, just by running Check50 in their terminal. So let's see what that might look like if a student were to run it. So on the back end here, Check50, like Submit50, behind the scenes pushes students' code to GitHub into a repository identified by the student's GitHub username into the Check50 organization rather than the Submit50 one. It's written in Python, and it uses that CS50.yaml file as does Submit50 and Lab50. So in terms of creating checks, you'll need a CS50.yaml and maybe an init.py file. And we'll see about that in a moment. So when a student runs Check50, what they'll do is they'll run Check50 followed by this unique identifier here. Again, referencing the organization, the repo, the branch, and the file path within that branch. They'll authenticate with their username and their GitHub username and password, and then Check50 will upload this to GitHub. It will run these checks in an AWS instance, and then we'll give the student feedback. So in this case, the student did pretty well. They passed all of these checks. We can see here from these smiley faces. And at the very end, unfortunately obscured by this a little bit, it'll output a link that students can use to see more information about these results. So we'll see what that looks like in a minute. So here's the highlighted version of everything I just said. So let's see a little bit more about the help link. So this is what that would look like if we clicked on that link. We'd see first of all the student's username, the problem they'd submitted, and then a log for each check of what Check50 actually did. So more than just this sort of message like input of 0.41 yields the output of 4. We can see what that actually means, what input we actually ran it on, what output we expected, that sort of thing. And if they got something wrong, it would say, we expected this output, but you gave us this output, or something like that. So for the CS50.yaml file, minimally, just like for Submit50 and Lab50, all you need is Check50:true. This isn't that useful. All it tells Check50 is that this is a valid repository for checks, but if you haven't written any checks yet, it's not going to be a super useful suite of checks. So just like with Submit50, you can specify files and patterns to include, exclude, and require. Jelle already went over this, but in this instance, we have the suffixes right, so that's good. For very simple checks, you can actually write these checks inside the YAML file itself. So we see this checks key, and our first and only check here checks that this hello.c file actually prints hello world. We can see that it compiles the code here, and it expects an exit code of 0, which means the code compiled correctly. Then it runs the student code, expects the string hello world with a new line at the end on standard out, and asserts that their code actually executed correctly and had an exit code of 0. However, YAML is not yet Turing complete, although with each passing year, the spec gets bigger and bigger, and it seems to be getting close to that. So for more complicated checks, this YAML syntax isn't going to cut it. And so for that, we have checks written in Python using Check50's own API to smooth over some of the more difficult things, which we'll see here. So I've started off by doing from Check50 import star. This is mostly for conciseness on the slide. This is not necessarily a practice that we recommend. However, the first thing that I would want to draw your attention to is this check, what Python calls decorator, this @check syntax. All that specifies to Check50 is that this is a function. This function represents a check. So when you're told by the CS50.yaml file to run these checks, run these functions and check their output. Then we can see that this check decorator optionally takes an argument. If it takes no argument, the check has no dependency. If it takes an argument, this argument indicates a dependency of a check. So for example, if a student submitted or tried to check something that didn't contain the file hello.c, there's no sense in trying to compile it. So there is one reason for this notion of dependencies is purely performance. On the other hand, it also prevents the student from seeing a whole bunch of red frowny faces, seeing that they failed a bunch of checks, because if you're presented with that output where it looks like I'm failing every single test case here, it's not necessarily clear where you should start, right? Instead, we sort of want to highlight the check the student's failing, and then for all the checks checks that depend on that just say, we can't even run this check until you try this. So that way, when a student sees the red frowny face, it indicates like this is specifically what you need to look at. So this is what that output might look like. If I submitted hello.c and that file actually did exist, but it didn't compile, there's no sense in telling the student you failed. You failed because your program didn't output hello world, because that's not really the issue, right? The issue is that it didn't compile, and so that is sort of what this notion of dependencies allows us to show the students. Then we see the student visible description of the check. So that's in the form of what Python calls a doc string. It's just the string that exists at the beginning of every function. So hello.c exists, hello.c compiles, etc. And we can see that reflected here. And then, oops, sorry. For a little bit more complicated checks, so in this instance, perhaps we want to allow the students not just to type hello world all lowercase. Maybe we want to allow them to capitalize hello, and maybe we also want to allow them to be particularly exclamatory and end it with an exclamation mark. So the Check50 Python API allows us to match the student output against regular expressions, if you're familiar with those. So in this instance, we allow the hello world string to contain either a capital H or a lowercase h. And this question mark after the exclamation mark indicates that this exclamation mark is optional. They can include it or not. And then here, the second string, this hello world with a new line at the end of it, is what is actually shown to the student if they don't match this pattern. Because if students aren't familiar with regular expressions, you wouldn't want to say, we expected hello world with a new line on the end of it, but you gave, or excuse me, we expected this bracket h, lowercase h, whatever, because students might think I actually have to print out square bracket, capital H, lowercase h, whatever. So that's what this additional string is here. And this is what we'd actually show students if they didn't match that pattern. And then if you want to get even a little bit more complicated and provide, if you want to provide feedback to the students that's specific to their input. What I mean by that is a really common thing that people forget when starting with C is that printf doesn't print a new line at the end of things, right? So, but we do require that hello world prints a new line. And so in that specific instance, we want to give students an additional piece of context, an additional push in the right direction to add this new line. So what we do here is we step a little bit outside the Check50 API. We do the regular expression matching directly, but we check if it matches this regular expression. If it matches the regular expression containing the new line, then obviously they passed. But if it didn't match that, but it did match one not containing the new line, then we say, we also pass the additional message, did you maybe forget a new line in your printf string? And so that's what that might look like. So if I ran Check50 on a file that just printed hello world without that new line at the end of it, they would get this additional piece of context. Did you forget a new line at the end of your string? So writing the checks becomes a little bit more complicated if you do that, but you can provide a little bit of extra feedback, and we do that in certain instances. So this was Check50, a tool for automatically assessing the correctness of student code. Now let's talk a little bit about Style50, which is our tool for assessing the style of student code, which is another thing that we think is very important. Before I describe the tool, I should introduce a little bit what we mean by style. So from CS50's perspective, Style50 is is indentation, white space, things that don't affect the execution of a program. And you might ask, if that's the case, if white space and indentation doesn't affect doesn't affect how the program runs, why does it matter? And this is the question that students have. And the answer to that is sort of twofold. One is that if you're going to pursue computer science as a career, companies enforce style guides, and so you have to do that because if you want to work at that company, that you need to write in that style. But maybe the more convincing or the more important reason is that not only is code a way of communicating to a machine, it's also a way of communicating to other developers, right? So if your code is unreadable, if there's no indentation and no one else can suss out what exactly you were trying to do, then you might as well not written it at all in many instances. And so I'm sure as computer science, if you are indeed a computer science teacher, I'm sure you've seen stuff like this. I know I definitely have. And this is very difficult to grade. So another reason for Style50 is it makes it easier for people grading this code to make sense of it, to both grade it automatically and give students the tool to try to make them style their code better. So what Style50 does is it tries to show students how to style their code correctly. So there's sort of two existing ways to do that. One way is to, in a sort of linter-like setting, output a list of like line number and column index, saying at line 3, index 27, you're missing a space here. But that's a little bit that's not super clear to students because I mean that's not even clear to me. On the other hand, there are tools that automatically correct the style of code or automatically make it conform to a certain style guide. And that's maybe going a little bit too far because it's still important that students know how to write correctly styled code. And Style50 tries to walk this line in between these two. So Style50 checks the code for adherence to our style guide, and it displays the changes the student should make visually without making those changes for them. And if you want a little bit more information on our style guide, you can find it on manual.cs50.net. So a student might, in order to run Style50, a student would just run Style50 in the name of the file. And we can see with this incorrectly styled code, over here, Style50 displays in red what they should delete and in green what they should insert. So in this instance, Style50 is recommending that they delete a space and insert a new line, so therefore moving this bracket onto the next line. It's recommending that they insert spaces around this plus and the 1 and indent this printf thing, this printf call. And so again, this indicates to the student visually what changes they have to make without making those changes for them. Style50 also has a couple of other output modes to display the changes in other ways. One is the sort of 2-column output. Another is more along the lines of the way GitHub displays diffs. This one is particularly of note because it's helpful for students who are colorblind. Some of these other modes require you to be able to distinguish green and red. This one with the minus and plus along the left side allows you to still distinguish what you should insert or what you should delete. And then finally, once you fixed all your style, Style50 just tells you that the styling looks good. So not sure what this is. So this is a bug in my slides. I apologize. I should run check 50 on them. So Style50, another thing Style50 does for us is it automates grading. And so what you can sort of see here is that one of the ways that Style50 can output information is to output just a score, which is just a real number between 0 and 1, indicating 1 being perfect style, 0 being completely terrible. And this allows us to automatically grade style. So no more do we necessarily have to have teaching fellows concerning themselves with grading the style of code because Style50 can just do it for you. And again, so this is where you can find the documentation for style for Style50. Although I think most of it has been moved to cs50.readthedocs.io. And so this was Style50.
So just 2 problems to solve. One is that of error messages. So there was this whole session this morning actually on error messages and improving them or interpreting them for students, because undoubtedly quite a few command line tools especially are doing students no good service with the arcane wording that they tend to use. The reality is we don't want to necessarily hide all of that detail because they're going to see it in the real world, and it is a good thing that they understand it ultimately. But we'd like to ultimately help get that text out of the way so that they actually understand conceptually what it is they've done wrong. So you're about to see a tool we call Help50. This is a tool that largely accepts the reality that tools are not necessarily going to have instructive error messages and accepts that via regular expressions and translates them into TA-like rhetorical questions typically, much like you and a person might do, saying, well, maybe did you remember to put a semicolon at the end of this line? This tool aspires to do that. We happen to use it for C and Python, but it's extensible to any number of languages. And with that, we'll have a quick demo from Kareem.
All right. Let's get back to this. Sorry, once again. What's it? OK, what's the? Is it escape? OK, same tab. All right. So right here, we're using the CS50 IDE. And I have a couple of demo files here. One of them is hello.c, and it includes a simple C program that has a bug in it, a syntax error in it, right? And the way to basically run Hel50 would be to, first of all, a student would run a command, make hello, and get some sort of overwhelming error, probably. And so the way to sort of have a more user-friendly output of this error is to run Hel50 make hello. And what this does is basically Hel50 runs the same command that the student passed to it, and then gets the output of this program, parses it. If it identifies an error message that it knows how to help with. It basically highlights the error that it matched against, as we can see here, and then displays a more sort of user-friendly error message. In this case, try including a semicolon at the end of line 5 of hello.c. And so I have another quick example. So I have hello1.c here, and this one has another bug that I forgot to include one of the header files. And so again, if I run make hello1, what will happen is I will just get an overwhelming number of errors. Implicit declaration of function getString is invalid in C99 for a student who's coming into programming computer science for the first time. Like, this makes no sense. So what they would do is run hel50, make hello1, and again, same thing happens, and it gives them more user-friendly. In this case, it advises them to include another header file called CS50’s from our CS50 library. So let's present this. OK. All right, so this is how you install hel50. Hel50 is a Python package that's available publicly. Anyone can install it by running pip install hel50, assuming Python is installed in your machine in pip. And then to use it, obviously, you run hel50 and then command. Hel50 is also open source on GitHub. Anyone can view the source code for it, and anyone can contribute to it and extend it further. We happen to use it for C and Python, but you can extend it to any other language, and it supports actually a bunch of the output from a bunch of other tools as well. Hel50 also has a web interface, as you can see here. Students don't even have to install hel50 locally or in their environment. They can just go to help.cs50.io, copy and paste the output of their error messages, and then let me actually demonstrate this real quick. So if I go to help.cs50.io, and then copy and paste the error, the output error from my IDE. So let's just highlight this. Oops. OK. Let's copy this. Let's try to paste it here. And again, hit help, and then they will get essentially the same user-friendly message in their web browser instead. All right, so here are the tools that hel50 currently supports as well. So among them is Bash, Clang, CP, Flask, and more. But again, these are very extensible. Anyone can add any more messages to these if you're using something different, or if you want to improve any of these. So that was hel50. Thank you so much.
So last but not least, we've got this tool via which we can help students. We've got this tool via which we can provide feedback on style, this tool via which they can check the correctness of their code, the tool via which they can submit their code, as well as those web-based UIs with which we began, the sandbox and lab. Unfortunately, sometimes students use Submit50 or any tool to submit not only their work, but perhaps someone else's, or one on which their own code is unfortunately based. And of course, some of you might be familiar with tools like Moss or other tools out there, most of which have generally been closed source, or at least hard to access, or have been web-based, and you can't necessarily run them locally or on-site and really keep things to yourself. And they certainly can't be very easily extended if you want to actually integrate it into your own system or even run different heuristics on students' code. And so thus was born our final initiative today, Compare50, a command line tool via which you can compare student submissions for similarities, either two students side by side or a whole corpus of submissions, both present and past. This is very similar in spirit to Moss, and in fact, it will output HTML, but that HTML is actually stored client-side so that you can actually run this locally, although version 2 of this will also make a web-based version like help.cs50.io so that you can compare students' code online. And for that, allow me to introduce my final colleague, Erin.
Hi, everyone. So as David mentioned earlier, a lot of the sort of solutions that we develop are based on problems that we face. So Compare50 was sort of a tool that we developed to solve the problem of checking for plagiarism. So right now, there's a tool called Moss that currently you could access via moss.stanford.edu. And when you run student code on Moss, you get something like this. So not entirely all that visually appealing. You get a lot of code. And as Chad sort of alluded to earlier, this whole idea of using color to identify differences is not great for a colorblind audience. So I can kind of see that maybe red is indicating similarities here. Black is maybe indicating things that are unique to each file. That's not entirely intuitive to me. There's some percentages at the top with some links, it looks like, and some progress bar in red. So not super user-friendly. So what we did was we created this cool tool called Compare50, which is using an algorithm called winnowing to make these comparisons. And it's one of our tools that's still in development. So this is the command line that you would use to install it. So there are a few ways to sort of use this at the command line. So one is Compare50, and then the paths to the 2 files that you want to compare. So this is the most simplest version of running this program. And what it's going to do is it's just going to look at student 1's program and student 2's program and sort of go through line by line and sort of figure out like what's similar and what's not. The other sort of use case, and we've seen include and exclude in a lot of our other tools, is it's going to, and again here, order matters, right? So exclude is saying, OK, just eliminate all the things, and I want to start from scratch, and I want to include all Python files and all C files here. So some of the features that we've built into this platform is ignoring distribution code. So oftentimes, teachers provide students with some base, and then they add to it. They fill in these blanks. And so we don't want to really get students for using our distribution code, because that was the whole point, right? We wanted to provide them with this code as a baseline. So all of our students are going to have that in their submissions. We've also wanted to be able to compare against student archives. So for example, our course has been running for 10 or so years, and we have all of this data that we've collected over the years. So we decide to also run our code against that. And maybe a student had a sibling who took the course years ago, or a cousin, and like, hey, can you send me your files for that? I don't want to do this homework assignment. I'm really busy this week. So we're able to run it against all of those archives as well. So one way you might sort of go about doing this is by using our flag distro, so dash distro, with the path to those distribution files that you've provided to students, as well as dash archive, which is going to be all of your previous data that you've collected from student submissions in the past. And again, those two can be shortened to -D and -A, respectively. So I'm going to hop into the terminal, and I'm just going to do a quick demo to show. Oh, let's see where I am. All right, so I have a bunch of students. Well, I have 2 students here. I have student 1, student 2. So let's look at what this might be like if I wanted to just submit or compare the files in student 1's folder as well as student 2's folder. So this is comparing both of those things. There's only one file in each of those folders. So I'm going to go to that web URL that it told me to. And I'm brought to this sort of index page. And I can click on that match. And right here, you can see that both files are completely highlighted. So these two are identical. You'll notice a few things in the sort of UI here. You'll see a percentage at the top. So that is mapping how much % of student 1's code is similar to student 2's. So for example, if student 2's code was twice as long and all of it was included in student 1's, theirs might show up as 100%, whereas student 2's would only show as 50%. And there are a few other sort of features built in on the left side. So we have structure, which is the view that we're in right now. And what structure does is it ignores sort of the things that students might change to make their code look different but function the same way. So what it does is it ignores white space. So students might be like, I'm going to add in some extra spaces, or I'm going to change variable names, or I'm going to change string literals, so prompting messages in your code. So this ignores all of that and says, look at the lines of logic. Do they match up? Another method that we use to match is exact. So what exact does is essentially the same thing as a string compare. It's looking for subsets of code that are exactly character for character the same. And one thing that we've sort of built in that doesn't really exist in some of the other platforms out there is a matching method called misspellings. So one way that we are able to, sort of a smoking gun that we're able to tell 2 students have definitely looked at each other's code is in their comments. And specifically, comments where they misspell the same words in the same place. And that is especially useful if we're bringing this case to someone in administration who may not be able to always tell sort of at a technical level what's going on. Being able to see something highlighted like this and very visual for them is important. So as David mentioned, all of this is running locally, and I have all of these HTML files locally. So what I could do is it generates a folder. And within that, I have both of those HTML files, the index as well as the specific match. And I can just send that to my administration. And then they can open that HTML file and see all the same highlighting that you saw when you ran this. But the typical use case is that you don't have 2 students. You have many students, and you have lots of distribution files, and you have lots of archives. So you can also run this for your entire class. So I can do the same compare 50. That's not what I want. Compare 50 line. And I'm going to, oh, yeah, I need to go back. So I can run compare 50 again. And I want to specify the path to all of my student submissions for a problem that we have called Speller. So within Speller, I have a folder for each student. And within each student's folder is all of their files. In this case, they have 2, dictionary.c and dictionary.h. I also want to get rid of distro for this assignment because we have a lot of distribution code in this, and I don't want that to give me a lot of false positives. So I'm going to ignore everything in this big file called distro. So this is doing a little bit more heavy lifting. I didn't compare my previous match to distro, so this is going to take a little bit longer. But essentially, I can go to that same URL. And I will now see a longer list of submissions. And I can click on that again and see our dictionary.c files. You'll notice that these aren't exactly the same. They're both 84% similar to each other. I can scroll down and see the other files that they've submitted. So there's also dictionary.h at the bottom. And all of this big chunk of yellow is the part that is matching structurally. So you'll notice that some of the comments are a little bit different. Some of the variable names are different. So if I actually went to exact, a lot of that isn't there because they've changed those things. There are a few sort of parts at the bottom that are exact matches, but those are kind of portions of the code that don't have a lot of comments to begin with. So these like if-else blocks are exactly the same there. We can also scroll through our different matches. So here I have a total of 50 matches, and I can sort of go through the top ones and look at which ones I want to either write cases for or talk to the students about. If they are on the verge of something that you may consider crossing the line in your own academic honesty policy, that's sort of where we determine, OK, this is OK, and this is clearly not OK. And again, you can sort of cycle through those different matching features there. I will note that misspellings is using an English dictionary. So some of the CS terms that we use in comments will get sort of matched as those false positives. Like HTTP, they included a link here because we do require students to cite things in their comments if they're using like a hash function from somewhere else, for example. So that's obviously not an English word, so that's going to show up as a misspelling in their comments. And yes, I think that that is all for Compare 50.
Indeed. Thank you to Erin. So where can you find out more information? So documentation for almost all of these tools is currently at this link here. If you go back to that very first URL, cs50.ly/talk, are these very slides, including all of the URLs, all of the GitHub repos. And indeed, let me thank our special friends at GitHub for allowing us an opportunity to share all of this, and honestly, for implementing so much of these tools for us. Well, we're happy to stick around for one-on-one questions, but thank you so much, especially to CS50's team, who's responsible for all of this. Thank you for coming.